Okay, good morning, everyone. My name is Mrs. Douglas. I'm responsible for mathematics at Homer Green Senior School. I'm an assistant head at the school, and I would like to give you a brief understanding of what maths is like at Homer Green Senior School. We're a very successful department, and over the last 4 years, we've been in the top 10% of schools in the country for progress, and we've actually hit the dizzy heights of being in the top 1% in 1 year. And last year, our results were 70% A's and above, and one of our students achieved an A star, which was exceptional work indeed. Okay, so what I'd like to do is just tell you a bit about what it's like doing maths at our school. So just bear with me, and I will share a presentation. Okay, so let me just apply this for a minute. Okay, right, so there's a presentation here that I'd like to share with you. There we go. Okay, right, now, so let's get to the top of the presentation. A-level maths at our school. Well, first of all, let me introduce the teachers. So there's myself, Mrs. Douglas, and I teach both year 12 and 13, and I teach the pure element. Mr. Ortega is our mechanics teacher, and he's got several years experience of teaching mechanics at our school. And Mrs. Hill will be teaching year 12 this year, and she will be teaching the pure element. And Miss Cummins is teaching year 13, and she will be teaching the pure element in year 13. Okay, and we all have many years of teaching A-level maths, and we work incredibly hard for our students, and our students work very hard for us. Okay, so now let's work on what you'll be actually doing when you're with us. So pure mathematics is 2/3 of the A-level, and the rest is statistics and mechanics. So 1/3 is statistics and mechanics. And that is equally shared between stats and mechanics, so 1/6 each. Now, the pure mathematics element of it takes algebra very deep. So if you don't love algebra, then A-level maths is going to be perhaps a struggle for you. But you know, if you love algebra, then A-level maths is the place for you. So the types of things that you covered in year 11 on transforming graphs, on inequalities, on quadratics, solving equations, looking at straight lines and circles will be extended far, far deeper. There'll be such deep learning on these concepts, okay? So you will be looking at, instead of quadratics and cubic, quartics. You'll be looking at sine curves, cosine curves, tangents, and much, much more diverse curves like cosecs, cots, sec curves that you have never ever heard of before, okay? Which will then take you far deeper into trigonometric ratios, into identities and equations. Vectors will be a significant part of mathematics as it was in year 11. And you will see a different side to finding gradients and area. You'll be using something called calculus, and calculus includes differentiation and integration, and differentiation allows you to find a gradient, and integration allows you to find area. So you'll be looking at very different ways of finding gradients and area. Proof will be something that will run throughout the pure element and is a very important part of what you'll be studying, as it's something that is needed later on at university. So it's an element that's been brought in recently. Okay, now going on to the applied side, you've got statistics and mechanics. Now, statistics very heavily supports you if you're doing subjects like psychology and biology. Okay, And you'll be doing things like measures of spread, measures of location, correlation, probability, looking at various distributions like binomials and normal, and then you'll be doing hypothesis testing to see whether an idea is significant or not. Okay, so that will link you very, very closely with psychology and biology. And then you've got the other applied element of maths, which is mechanics, and that ties in very strongly with physics. So it's how do things work, and it's the maths behind it. So the constant of acceleration, forces and motions and pulleys and variable acceleration, okay? So that gives you some idea of what you could potentially face over the 2 years, and each year you'll be going into deeper and deeper learning of these concepts. Now, we will provide for you all your books, so you don't need to buy any of those. All 4 books will be provided for you. The only thing we would like you to provide is the calculator, and you can purchase this through Amazon for £26.63. Okay, pence. Now, moving on to why we are so successful in the maths department is that we have the teachers and the students have a very, very close relationship, and we work very hard for each other. Lots of questions are done in the classroom, and any question that you don't attempt in the textbook is then attempted after school. So people ask me why are the students so successful? And, you know, I often say to them, if you do every question in the book, you've got an excellent chance to get an A, and on a good day, you could get an A star. All right, so those textbooks are key to it. Complete every question and you will do exceptionally well. But it's not just about completing questions, it's about making sure you understand, and the understanding is asking lots of questions of your teacher to really stitch together your understanding of the maths that we will be looking into, okay? And when you are doing work independently at home, if you don't understand, don't leave it, come and find us, sort it out, okay? It's very important to keep on top of the subject, otherwise it will run away from you. Another way of us giving you feedback will be through unit tests, and you will have regular, every 2 weeks, unit tests. And these will be small, but what they will do is they will assess your understanding of what's just been taught to you. And if you're achieving 80%, then you should feel very happy. Anything below needs to be sorted out, okay? Because it's only just been taught to you. So those unit tests will be key because they will tell you every 2 weeks how you're getting on. Now, as well as that, we will give you half-termly tests, and this will tell you whether you've retained over the 7 or 8 weeks that you've been with us, okay? And if something has just left your memory, in which case, then you need to go back and revise it. And then you've got the 2 mocks that we will give you per year. That will tell you whether you've understood anything in the whole term or a term and a bit, okay? So these assessments are key. So again, reiterating that it's that partnership between students and teachers that brings about the success. So we work hard and we expect our students to work hard. Okay, so what I'm going to do now is do an example with you. So let me just play around with this and remove the background. And just bear with me so I sort this out. Okay. I'm now going to connect you to a question. So hopefully you can see a blank piece of paper. And the question that we are going to do together is we're going to show we're going to show that 1 over root 1 plus root 2. Just let me write it down first. Okay, so this pattern of fractions is all equal to 4. That's what we're going to show. Okay, so I'm going to give you a little bit of a hint. You can see that the result is an integer and there's no surds in sight. So the hint I'm going to give you is look at each of these fractions in turn, all right, and see whether you can rationalize them so that there's no surd as a denominator. All right, so that's your first hint. And I'm going to just do the first one with you. So the first one, for example, if I just draw a line there. If I were to rationalize just this fraction, I know I've got to multiply the top and bottom by the conjugate. Okay, so we change that sign like so. Okay, so 1 times that just remains as that. Now the denominator, if I use my grid, hopefully you can see it. Remember there's a minus there. Well, that's just going to stay, that's going to be 1. That's your root 2, and there's your minus root 2, and that becomes minus 2. So our surd cancels out. Okay, so root 2 minus root 2 disappears, and we've got 1 minus 2, which is minus 1. So the first one, when I rationalize it, okay, ends up with a root 1 as a numerator, root 1 minus root 2 as a numerator, with a minus 1 as a denominator. Now, if you then do the same to that, you should see some sort of pattern. Do the same to that one, you will see a pattern, okay? And then do the same to that one and see what you discover. So stop the video for now and then come back and join me and see what you discover. Okay. Okay, welcome back everyone. So if you were then to rationalize this fraction, you would have root 2 minus root 3 at the top as a numerator, and minus, what would you have, minus 1 as a denominator, root 3 minus root 4 as a numerator, and minus 1 as a denominator, dot, 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 dot. And here you'd have root 24 minus root 25, and minus 1 as a denominator. So hopefully you've got that pattern. Okay, now question is, how do we get to the 4? So if I divide through by minus 1, I'm changing the signs. So that becomes negative root 1, positive root 2, negative root 2, positive root 3, negative root 3, positive root 4, and so on. Hopefully you got that. Positive root 25 at the bottom. Okay, now then you will probably notice that these cancel out. These cancel out, and then you would notice that that cancels out and that would cancel out, and all you'd be left with is the first term and the last term. So let's write those down. Minus root 1 plus root 25, and we know that's minus 1 and that's 5, okay, which gives me 4. There we are. Well done everyone. Hope to see you soon.